Hi, this is Andrew. Thanks for watching. This is a video that covers the basics of setting up first hop redundancy protocol and specifically Cisco's proprietary hot standby router protocol. This video uses a packet tracer environment that I created just to show you how things work, to show you the process. This is not the packet tracer that you're going to be using in class. You'll still have to do that on your own just based on the knowledge you gain from reading and from this. This is just an example of the process. So first, a few basics. HSRP creates a virtual router that devices on the network can use as a default gateway. The virtual router's address is then used by the active router so that it can send information through. If the active router fails, then the hot standby router will take over and nothing needs to change on the device. So let's look at the environment I created. What we have here, just notice that you have a PC here, and on that same network you have two routers, which is kind of a rare situation. You would normally have a single router leaving the network. Problem with that is that router fails, then this PC can't get out. And if it's critical, then that would be a problem. Or if you have a larger network and you want to have redundancy built in, here's a way to do it. So what happens is we have R1 and R2 on this network, and kind of in the middle we have a fake address for the two, and then whichever one is the active router will take that traffic and then send it on to R3. So let's look at the environment first. We have this network down here, this whole section here, 192.168.0.0/24. Then connecting R1 to R3, we have 10.0.1.0 and then 10.0.2.0 connecting R2 to R3. And then this network up here is 10.0.0.0. So on both ends we have 10.0.0.5, which is our server, and 192.168.0.5, which is our PC. So the idea is right now if we look at the PC, it is configured with 11 as the default gateway, and that's R1. So if I just go to command prompt and ping 10.0.0.5, I get there, and that is going over R1. And if I were to go in and change the default gateway to 12, we can get there that way as well. So I will ping it again, and we're getting there that way as well. And if we did a trace route, we would see it's going through R2 now. Obviously, so this is, I guess, some redundancy, but the problem is we need to change that configuration. So let's go into the routers, set up HSRP, and create a situation where a router can go down and the PC can, without changing any configuration in the PC, it can use the other router. So we are on R1, and again, a little bit of sloppiness. Let's call it R1. So we are on R1. Let's run a configuration. First thing, these interfaces are G000, and we can do show IP int brief. 000 is the 192.168.0 network. That's the section down here. That's the section we want to have as our interface that will be configured with HSRP. So we do int G000. We're in that interface now. Now we are going to say we've already configured an IP address on here. So we're going to tell it we're going to use standby version 2, and we're going to standby 1. That's telling it which group number. We're going to give it the IP address that's going to be the virtual IP address, 168.0, and we're going to use a standard default gateway address, 1. So this is 192.168.0.11, but we're going to say use this as our virtual interface. 1. Now we want to set a priority on it. Default priority is 100. We're going to set this one as the higher priority router. So let's stand by 1, priority 150, and we're going to tell it to take over as the router, as the active router on that interface, on that 192.168.0.1 address. So we are all set here. Actually, one last thing I'm going to do, because we're going to be testing this out, I want to copy run start, because I'm going to actually power cycle this router as part of the process. So now let's set up router 2 to be the standby router. Enable T, and once again do show IP int brief. 000 is our IP address on this network, and in this case it's 12, as we saw when I was changing the settings on the PC. So we are going to interface G000, and let's do standby version 2 again, and standby 1. We're telling it which group it is and what our IP address is. IP 192.168.0.1. So we have everything configured. Let's do another copy run start. Okay, so it is all configured right now. Now one more step we need to do. Actually, we'll run show commands, but before we do that, let's go in here and set that as our default gateway. We're no longer using 11 or 12, we're using 1. And with 1 as our default gateway, we should still be able to ping. And if we do a trace route, a tracert to that server, we should see that we're going over 11. That is R1. So that's telling us everything's working as expected. So even though we have our default gateway set as 0.1, we have our trace route is showing it's going over 11. Good shape. So now let's do some show commands and see what's going on these routers. So we're going to start with R1. We're going to show standby. And in here, this is R1. We're saying state is active. That means that this is the active router. Virtual IP address is 192.168.0.1. The active virtual MAC address, that's where basically it's saying if you get anything for this address, send it to this MAC address, is that MAC address there. And it's saying the standby router is 192.168.0.12. So let's look at R2 and do the same thing. And let's move this here. Show. And here, state is standby. So its standby router is local. We have our active router is 0.11, which we saw over here, and the virtual IP address is the same. Okay, so we have a situation where if PC1 wants to talk to server 1, it goes through R1. So if we go to R1 right now, go to physical, and we can power it off. See, everything went red there. This router is powered off. Now we go to PC, and let's see what happens if we, let's start with a ping, and we are going through and getting there. So now let's run a trace route. Now it's going 192.168.0.12. So that's going the way we want. Now we can run, and actually we can see the messages there. Gigabit 00, group 1 state standby to active. So we can also run the show standby command again. State is active, and it's virtual IP address. It's saying it's active. Standby router is unknown because there isn't one, because it's powered off. So that is, again, doing everything we want. Now let's see what happens if we turn it back on. So if we go back, we'll hit the power button again and watch the command line as it boots up. And it's fun watching these things go. And as it's doing that, let's give it another trace route. Ooh, I think it just, let's switch back to the router. We're gonna have to wait 30 seconds. So if this switch were set to not wait the 30 seconds, it would have come up already. So R1 is enable show. So it just said state speak standby, state speak active, standby active. So it actually just switched from standby to active. And let's see, show standby, and it is now active again. The standby router is 12. If we go back to 12, we can run our command again, and it's saying it basically went back to standby. So let's see that happen. Show standby, we have state is standby, and active router is 11. Back to our PC. Let's run our trace route again. And there we go. Just took a second the first time through. 192.168.0.11 is now going through. So that is HSRP. That is showing that if we have a PC here pointing to a virtual router, we can turn, and the routers are configured as I showed you. You can turn them on and off, and there is a standby route that they can go through to reach the endpoint. That's all I have for you today. Thanks for watching.